Now you guys seem to carry a lot of stuff.
We do. Yeah. We do carry a lot of stuff. Charlie said I look like a Christmas tree with everything that I was carrying. So for this dive, we've got knives to help us break the corals off.
Shark shields, of course.
Shark shields.
So they're ankle cuff shark shields. So they are meant to deter sharks from coming too close to us. And they send out an electromagnetic signal through the water to deter sharks.
Then we've got several cameras. So we've got this camera set up for macro. So we're going to try and get some really good images of the eggs. 2 GoPros to try to just get some footage of what the site's like. And then
sampling slate,
yeah,
data.
Bags for collection of the corals, so we know what the data relates to for the one we took, and another camera. So on the dives we are looking for our target coral species. These are select species that seen at TTS and also at AIMS are looking to target to see what their physiological traits are and also their genetic traits to try and understand how they survive some of the worst physical events that there is to see. So on the dive we're swimming around trying to find these species. Some sites we find them very easily, other sites we're really having to hunt these species. Once we find them, we carefully remove the fragments from the parent colony. And we look for species, we look for individuals from that species that look relatively healthy, so don't look like they've got disease, but we look for different colour morphs. So, for example, some of them have fluorescent colours, which is a sign of stress, and some of them are paler than others, so they've got different symbiodinium amounts within the coral tissue. So we select these individuals to bring back on board a boat where we'll run some coral incubations, and these incubations will undertake to try and understand what some of the physiological traits are that are facilitating their survival. We have brought these samples up from the reef and we're now fragmenting them so that we can put some in incubation chambers, and then the girls over here are getting some in tinfoil, so we're going to flash freeze them so that we can take them back and do all sorts of different molecular and metabolomic sample on them. And then Taylor's also putting some in formalin to look at fecundity, I believe, when they get back to AIMS.
I'm behind Sam's bar, which I commandeer on a daily basis to do my calorimetry and cell counts and cell volume measurements with the microscope. Okay, so what I've got here is a pan underwater fluorometer, and what that does is tells us about the chlorophyll fluorescence yield of our coral samples and basically the photosynthetic efficiency of our samples. I'll start one now. So specifically what I'm doing now are rapid light curves, and basically it's saturating light in pulses, and it brings back information about the photosynthetic efficiency of our samples and how they're utilising light, mainly electron transport through photosystem 2. And then this data provides really good kind of supportive data to all the physiology and metabolomics and genetics that we're running. So in the bathroom here, you can see our little makeshift lab. So what you can see here is an experimental setup that we've got, and we're doing this the whole way along the transect that we run on this GBR Legacy trip. And what we've done is we've got 2 different coral species, but 2 that have been abundant so far on the transects we've got. And what we wanted to see is, are there specific traits or properties of these corals that maybe have allowed them to survive the bleaching and do better over the course of the stress that we've seen. And so how they're using that oxygen or putting the oxygen back into the water depending on light or dark conditions, we can see how fit they are, and we can also measure how much they calcify, and that's really important because we know that the corals need to calcify to form the reef structure that obviously we need into the future. So yeah, you can see they're just sitting in here. So this is the first light incubation, so they'll be here for 3 hours. After that we'll take end water samples, end oxygen measurements, so we can get the difference over that 3-hour period, and then we'll cover them and put them to sleep, and it will be the dark incubation.